Hi, welcome to the Calculus 2 lecture series. This is unit number 2. This is our lecture number 1, the integration by parts. On the first video, we talk about how to apply the integration by parts formula. That means you integrate the UdV will be equal to the UV minus the integration of the VdU here. Like we did 5 problems practice to see how to apply the formula here. So for the second video, and we're going to redo some of the problems we did on the first video, but I'm going to show you a kind of a trick, okay, or we kind of an easy way to do it by using what we call is the table methods here. So I think the main benefit for the table methods is like it's kind of in a very organized way, and also it's kind of like a step by step. It's clear. It's not like you have so many like integration by part once, twice, 3 times. So you will see, I think the table way is very organized way to do it. And so now let's take a look. Let's go ahead and go to our lecture notes. Okay, so this is what we are going to take a look at x cosine 2x. So if you go back to what we did in the first video, so we talk about x cosine 2x. So when we use the table methods here, you still need to choose what to start. All right, so like you choose 2x and cosine 2x dx is dv is here. You will do the similars here. So now let's take a look at what I mean here. So when you do the table methods here, you do like this way. You put the 2 columns, and this column, you want to continue, take the derivative. And this column, you want to continue, take the integration. Okay, so now let's start. I said, okay, I put this is x here. Maybe let's try to use the color coding will be better here. So just like we did here, I put the x here. Then the integration part here, I want to cosine 2x here. Okay, so remember we say this column, I'm continue, take the derivative. So I know the x, when you first take a derivative of what will be 1, right? Then 1, you take a derivative, it's a constant. What is here? It's 0. Then you know you stop in here because here is 0. And now this one here, you do the integrations here. So cosine 2x, I know the integration, you still need to know the simple integration formula. So this will be the sine 2x over 2. Okay, now the next things here, you do continue to do integration. So it's a sine 2x. So when you do the integration, it will be negative cosine 2x. Then here's 2, then this is a chain rule. So this is a 4, right? So you still need to know what are the simple integration. Then you stop here. You don't continue going because here is 0. Okay, then the next things here, you want to put, we call it the sign here, all right? So in here, you always start with a positive sign. So you go like this, use positive, negative, positive. Okay, and then your final answer will just go this way, this way. Okay, so now let's see here. So my final answer will be the x times the sine 2x over 2, right? That's the first branch. And this one's here, right? So then times here, be careful. This is a minus, minus. So what is here? So this is a cosine 2x over what? So this is a cosine 2x over 4 plus c. Right, so it's a lot easier by using. So here, if you compare what we did on the video number 1, yeah, we got we have the same answers here, right? So like I said, you still need to know the basic, but then because this is a very organized way to do it, special, if you need to do more than once the integration by parts. So the table will be very organized to do it. Like this one's here, x squared e to the 5x. Take a look at what we did here. So this is what we did, you know, for the first video, it's here, right? So it's we kind of doing the integration by part once, and then we need to do the second time, right? So it's kind of getting tedious, getting long, right? The integration is long here. So now let's take a look at this one. Okay, so how do I use the table methods here? Okay, so the table method, yeah, let's go ahead. Oops, here. Okay, so let's here. Okay, so now let's do here like we did before. You put the 2 columns here, and then make sure this column you always take the derivative, and this column you take the integration. Okay, so now let's start. So I'm still calling this one as x squared. The reason why I want to do that, because the x squared, when I continue to take the derivative, it's going to disappear, right? So then the integration is here. So this one, I put this is e to the 5x. All right, so let's start here. So remember, this purple one, I'm continue to take the derivative. So x squared, what is the derivative? Is 2x, right? Then 2x, what is the derivative? Is 2. Then 2, what is the derivative? Is 0. Yeah, you know, I come to the 0. I know I can stop here. Okay, now let's take a look at the integration. So we still need to know the very basic integration. So for the e to the 5x, what is here? The integration is still the 5x over what? So the 5x will be e is itself, but by the chain rule, you need it by 5. Okay, now integration one more time. So this is the 5. And now, okay, this is the 5. Now e5x, integration still by itself, but by the chain rule, you need to times another 5 here. So this will be the e to the 5x to the what? 25. Okay, one more time, you need to integration. So the 25 is in here, right? Then the e to the 5x still itself, the e to the 5x. Then times what is here, you need to chain rule, it's 1 over 5. So this is e to the 5x, what is here, 125 here. Okay, now after you do that, now what is the next thing? Put the sign, right? So put a sign. So here, this is always start with a positive, negative, positive, negative, right? Okay, now you do a cross like this, right? Then you stop at here to 0 because it's not nothing, you know, you continue integration, then it will be 0, right? Okay, so now I can know my answers here. Let's see, it's really pretty, you know, organized way to derive it. So the chance for you to make an algebra error is a lot smaller. So this will be x squared e to the 5x over what? Over 5. Okay, then here's minus, all right? Minus 25 and 2, right? You have a 2x here and the e to the what? 5x. And then here, this you have the 2, so plus 2, 125 e to the what? 5x, right? Okay, so then don't forget, have a c's here. Right, so if you compare to what we did for the previous one, we got the same, we got the same answer. But you know, it's a lot nicer and way more organized way to do it, right? So you won't kind of get messed up with your algebra. Okay, now let's take a look at this sine x cosine sense. Okay, so the table method still will work. Yeah, right? So you do like this, 2 column. All right, so like we put in here, I'm choosing this one. Remember, this is the derivative column. And this is my integration column. All right, so now let's put here. So I put a sine x here. And my derivative part is a cosine x, right? So I put a cosine x here. Okay, now I start, right? So I start, so sine x, I take the derivative. What is here is a cosine x. Then the cosine x, when I take the derivative, when I take the integration, will be what? Will be sine x. Okay, so now you look at, so you say after you take the derivative and the integration once, RB darn, so the cosine x sine x is cosine x sine x is repeat as what we had before. So this is where you stop if you see a repeat here, right? Okay, so now you still do the same thing. You put the plus minus signs here. Okay, now you do like this. Okay, so now the last things here, this one you need to be careful, right? So this is the one you need to be careful here because they are repeat of what you have here. That's what you have here. Okay, so here the answer will be, so this will be, let's try to write it here. So that's what is the sine x cosine x dx is equal to, so here, right? So sine x, so it's sine square x. And then here, okay, it's a minus, right? So this is a minus, right? Cosine sine x, so you minus. So in here, because they repeat the same patterns here, you see here the same things like in here. So in here, you need to have an integration sign. So you will say this is the sine x cosine x dx, right? So it's exactly the same. So you need to add back this integration sign. So now you add both sides, right? So like we talked before, so you add sine x cosine x dx, then you add the sine x the cosine x dx. So your left-hand side will give you the 2. This is the sine x cosine x dx is equal to the sine square x plus c. So in order to find this, what you do here, you divide by 2, right? So that's what you have. This is the sine x cosine x dx is equal to what? 2 sine square x plus some c's, right? So c over 2 is just another constant c here. So that is how do we use the table method. So remember, when the table methods here, when you kind of see it repeat, all right, then you stop here. So like, let me show you one other examples here. So for example, I'm going to take the integration of the ex sine x dx. All right, so for this one, okay, so let's try this table methods one more time here, right? So this table methods here, let's see what happens here. Right, so for here, this one's here, this will be the derivative part. And this will be what? This will be our integration part. All right, so now let's start here. So you say, okay, I put the EX is my derivative part, right? Then the integrations here, I put the sine x, this is my integration part. Okay, so now let's take a look here. So derivative, oh, EX will just be EX itself. Okay, integration, sine x, what is integrated is negative cosine x. All right, I did not see any pattern here yet. This one does not go to 0 yet. Okay, so let's try to do one more time. The derivative EX. So the integration of the cosine x will be equal to what? Negative cosine x will be equal to the negative what? It will be equal to the negative sine x, correct? All right, so it will be equal to the negative sine x. Now the next thing here, let's put the let's put the signs, positive and negative signs there. Okay, so let's start put the positive and negative sign. Okay, so we start with the positive, negative, positive. All right, so in here I say I can stop. The reason why I can stop, take a look here. This will become EX sine X. It's exactly repeat what is my province here. So I know my pattern repeated here. Okay, so now let's take a look. What is this integration? I put here, here. Now I have repeated terms here, right? Okay, so let's try to write it. So this is the EX sine X dx. Okay, it's equal to negative EX cosine X, right? Positive, negative, right? And here it's negative, negative, it's a positive. Then plus the EX sine what? Sine X. And because this is a repeated term, so this one will become what? It will become negative EX sine X dx. Right, because it's the same, so I need to have this integration sign. So now I know how to solve it, right? Because the pattern going to repeat, there's no need to continue doing that because it's going to always be a sine, cosine, EX. So now because I see the right-hand side equal to, have the same term as left-hand side. So now I can say this is plus EX sine X dx, both sides, plus EX sine X dx, both sides. So what happened to your left-hand side? My left-hand side is 2 to the EX sine X dx. And what happened to here is negative EX cosine X plus the EX sine X. And plus some constants C's, right? So now you divide by 2. So now I finally get the answers here. So the EX sine X dx will be equal to what? Is the 2. I guess I can take the EX out and factor the EX out. And then here will be the sine X, the minus cosine X, then plus some constants C, right? So this is another example, when your pattern repeat and your derivative column will not going down, it's not going to 0, then you see you repeat the pattern as what you have original in the problem. Then you can stop in here. Then you use algebra to solve it. All right. So that's what we call this, the table method. As you can see, it's very, very, to me, I think it's very organized and clear. Try to find integrated by part, and it's not going to be very messy like here. Like when you try to do here, the chance to make the, the algebra error is a lot bigger, especially those negative, positive signs here, right? So we need to be very careful. All right, that's it. That is what we call it is the integrated by parts by using the table methods here. All right, that's it. So this is the first technique in this unit we learn is integrated by part. Then the next lecture, we're going to learn how to take the integrations, involve the trig function, and what type of technique we need to know. All right, nice talk to you. Have a good day. All right, bye.